for NEET is now available on the Google Play Store. Try it out for free.
Good morning, students. We have started IUPAC nomenclature, as you know, and a few of the very important things we have studied in previous classes. And that is one important thing is the IUPAC nomenclature of branched chain hydrocarbon. And a few very key points I'll just revise. And this is important because in the branched chain hydrocarbon, we have substituents, we have side chains, we also called branches. And these branches, we write their names as prefix, and those prefixes, the same pattern we will follow to write the IUPAC nomenclature of organic compounds containing functional groups as well. So today we will be starting IUPAC nomenclature of organic compounds having functional groups. But what we will see the main is that particularly some things of the numbering and the finding out the principal chain, writing the name of prefixes or means the branch chain. Those things are still that we carry forward, and those information that will carry forward from here, and they will still be useful there as well. So what we will see, so the longest continuous carbon chain we will have to look at that. Then this things will be also know the alkyl groups how one can name. And if you do not remember, you can just find out the alkyl chain, whatever the branch is there, you just count the number of carbon atoms, and if according to that would be the alkane, and with that just replace the last ane with yl, so it will be the branch chain alkane. And then no, sorry. And other information is identify the longest continuous carbon chain in the molecule. Then we will have to the numbering we have to done. And numbering is done in such a way that the carbon atoms at which branching takes place get the lowest possible numbers. In the case of functional grouping, some functional groups contains carbon atoms. So we start numbering from those carbon atoms. Most you can do other ways as well, but mostly we'll start numbering with that carbon atom. The carbons, if the functional group contains a carbon atom, then we'll start numbering from that carbon atom only, and then we will go up to the longest possible carbon chain. And if that functional group do not contain a carbon atom, then we'll do the numbering as per this rule in such a way that the carbon atoms at which branching takes place get the lowest possible number. And here in the place of branching, we'll see that carbon atoms at which the functional group is attached or linked gets the lowest possible number. Then we see that alkyl names of alkyl groups attached as a branch are prefixed to the name of parent alkane, and those things we have already seen. If different alkyl groups are present, they are listed in alphabetical order. This is an important point. Different alkyl groups are there, and what we have seen that in the case of polyfunctional compounds, the polyfunctional compounds, some of the functional groups are subsidiary or the subordinate functional groups, and we treat them as a substituent. So their name will also be considered in the alphabetical order when we write the prefixes for different compounds. And then if the two or more identical substituents are present, then the numbers present representing their positions are separated by commas. These are the points that we have seen, and the hyphens between number and letter, and uh, comma between two numbers, and so on. So if two different substituents are found at equivalent positions, give lower number to one that comes first in the alphabetical listing. This is one thing that is important. And why this is important? Because maybe suppose this uh, was, and that we'll see later on. And the branch, it may be confusing. The branch alkyl groups can be named by following these rules. And what are these rules? The branch means the branch if the branched alkyl chain is also having a branch. So this rule is for that. So alkyl groups can also have, I mean the branches, the side chains can also have branches in the in an organic compound, and we have seen this, how one can name them, and their name is usually put into the parenthesis. And what we do, we'll name them, we'll find out the longest chain even for the branch, but the numbering will start at the carbon atom which is attached to the parent chain or the main chain. These are the some important points, and this point, then if there happens to be two chains of equal size, then that chain is to be selected which contains more number of side chains. And this is point means if you see this example. So if you go from this side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 carbon atoms from this side, and what we get, the branches, number of branches will be 1, 2, 3. And if you consider this way, go this way and do the numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But in that case, only there will be only two branch, one branch here and one branch here. So what we will do, we consider this chain as a parent chain and not this chain. And this is because, as I said, if there are it happens to be two chains of equal size, and in this case two chains of equal size are there, then what we will do, we will select the parent chain which contains maximum number of substituents. So this we will choose as a parent chain because it contains three substituents, one, one, two, and one is here at the fifth position. And these things, these examples we have already seen. This example we have also seen, but I'll just briefly mention this. Alicyclic compounds. So a saturated monocyclic compound is named to be is named by prefixing cyclo. So whatever this is, if it is this is alkane, so what will alkane is already there. What will six carbon atoms, five carbon atoms are here in this compound. So I'll will do it is pentane if with the five carbon. But since this is cyclic pentane, so we'll write cyclo uh, prefix before the pentane and add together. So this is cyclopentane. And if there these cyclic groups have branches, so these branches should also be named accordingly. And how will we do the numbering? That depends on the rule already we have studied. Means we will follow the first alphabetical order if there these branches are at different positions. And if there is are more than two branches at the one position, then what we will see, the more branch carbon atom gets the lowest number. So if ethyl and methyl groups are here, so what we'll see, ethyl comes first, so the numbering will start from ethyl, then methyl. Or if the methyl and propyl groups are there, but we know methyl comes first, then the propyl, so the numbering will start from the propyl. So one can say here one methyl, three propyl, cyclohexane because six carbon atoms are there in the ring, so it is hexane, and cyclo because it is cyclic hexane. And here the numbering will start from here because 1, 1, 2 methyl groups will be at the first position, and what we have to do, the priority is always given to the this branch chain head branches gets lowest number. So this is the rule which gets in priority, and then we'll see alphabetical order if the numbering will be at the same, means if these branches get from the different directions get the same numbers. So one may also start numbering in this compound from here 1, 2, 3. But since either 1, 2, 3 or 1, 2, 3, you will not go from this direction, because in this direction if you go, that these branches will get more, their positions will be higher in the order. So maybe if you go from 1, 2, 3, 4, 5, so in that case branching will be one first and fifth carbon atom. So that rule will do not follow. We'll do the numbering this way, and this way we do not do because if different branches are there, they will see alphabetical order. Here, what will the more branch carbon gets lower number. So this is the more branch. It has two carbon methyl groups, and so it will get lower number. So 1, 2, 3, and so this is, although this is ethyl, the priority if you look at the alphabetical order, ethyl comes first, but will give lower means branching, higher number of branching, more priority than the alphabetical order. So and it means this rule, the numbering is done in such a way that the carbon atoms at which branching takes place get the lowest possible number. So this rule is for that, and this rule comes in the priority. So if I will start numbering from here, these two methyl groups gets one position one. So 1, 1, and then this is third. If we do this here, if we start numbering from here 1, 3, 3. So 1, 3, 3 will get higher number than 1, 1, 3. So the numbering will start from here 1, 2, 3. So in this case, it will be what will be the 3 ethyl. But while naming the name, what we will see, the this branch chain, their alphabetical order in their name. So ethyl E will come first, then dimethyl. So it is dimethyl, since dimethyl, 1, 1 dimethyl. These things we know. Now let's start nomenclature for organic compounds having functional groups. And about the functional groups we have already studied. So what is a functional group? If we know that the functional group is a functional part of an organic molecule, means functional part means what? If a certain group attached to an organic compound determines its chemical property, that group and the group of that group means a group of atoms. That group of atoms is called the functional group. Usually these functional groups are heteroatoms, means these atoms are other than carbon and hydrogen. They contain heteroatoms, at least one heteroatom. Usually, so usually until unless if there is no carbon-carbon double bond, we also consider double bond. Means this is alkene as also a functional group, or alkyne triple bond also as a functional group. Other than that, other than alkene and alkyne, all the functional group contains heteroatoms. Means heteroatoms atoms which could be nitrogen, oxygen, phosphorus, sulfur, or something like this, or the fluorine, chlorine, bromine, iodine, and so on. The presence of functional groups enables systemization of organic compounds into different classes, and based on these functional groups, and since they follow the same reactivity pattern. And what does it mean? Same reactivity pattern they follow? It means suppose if you have CH3OH, CH3CH2OH, CH3 twice CHOH. What we see that the number of carbon atoms, their structure are different. Although their structure are different, they give similar reactivity, and this similar reactivity means when they react with the sodium metal, what they liberate hydrogen. So they liberate hydrogen on reaction with the sodium metal. All this, and why this is because the OH group is common. Only thing that is common in all these compounds is the OH group. So compounds having the same functional group undergo similar reactions. This is the point that the very important point that we know about the functional groups. And that is why the presence of functional groups enables systemization of organic compounds into different classes. And so based on these functional groups, we divide organic compounds into different classes, and these different classes for different functional groups. However, what we also know, there are compounds which also contains many functional groups. In that case, then we will see the reactivity pattern or the reactivity order of different functional groups. The functional group which reacts first in a given chemical condition, then we will say its reactivity is higher, and so we'll see the compound is having basically the compound with the functional group which is having higher reactivity. So those things we have seen briefly, we'll see even today. So, so in writing IUPAC nomenclature, the functional group present in the molecule is first identified. So what we have to do, what is the functional groups and what are the different functional groups in organic compounds that I have already explained earlier, and how can you recognize there is a particular chemical symbol, and based on that symbol, if it is there, you can find out this is the functional group. Like here, if OH group is there, we can say this is the alcohol functional group. So all these are alcohols. All these three compounds are alcohol, and so the functional group is alcohol OH. Hydroxyl group is attached to a carbon atom, so it is alcohol. It is important. Hydroxyl OH group is attached to carbon atom. If OH group is also attached to hydrogen atoms in water. So, what water is a different chemical compound. So HOH, one can also consider if in the water structure, if hydrogen is replaced with some alkyl groups, whatever the length of that alkyl group is, that compound is called alcohol. So in writing IUPAC nomenclature, what do? We first recognize the functional group, and with that functional group, each functional group is given certain suffix, certain name to in writing IUPAC nomenclature. So if the functional group OH is given, we call it OL. So to represent whether it is alcohol, we will add OL as a suffix. Means OL we will add at the end of the name IUPAC name. So it represents, then in that case, if OL is written, you will understand it's all. You will easily understand the functional group is alcohol in that compound. So similarly, if the functional group is aldehyde, CHO at the end of any carbon chain, then you can add its name will be AL. The suffix that we add to write in writing IPC name is AL, all. So if al is written as a suffix at the last letter AL as the last two letters of any name, then you can easily identify, you can easily understand that in the given compound, the functional group is aldehyde. Or similarly, if CHO group is attached somewhere, and if that CHO group there is no other functional groups have lower reactivity than the CHO aldehyde groups, then the name will end at the SAL. So then in the appropriate suffix is determined accordingly, and for each functional group a suffix is already determined and given by the IUPAC, and that suffix that we have already seen, we add in writing IUPAC nomenclature. Then the longest chain of carbon atom containing the functional group is numbered in such a way. So these carbon atoms should contain the functional group. It means the carbon atom where this functional group is attached, or if the functional group itself contains carbon atom, so the numbering should also consider that carbon atom which is part of the functional group in such a way. So this functional group is numbered in such a way that the functional group is attached to the carbon atom possessing the lowest possible number in the chain. So in numbering should be done in such a way that this functional group contain lowest possible number in that numbering, and the compound's name is arrived at using suffix appropriate for the given functional groups and a compound name as I have explained here, and the prefixes that we'll already use whatever we have used till now. So what is the rule that we follow for the functional group is the prefixes. That means here it will be the branches and the root. Root will be what? It will for the parent structure, name of the parent chain, and the name of parent chain and the suffix which represents the principal functional group. And so the substituent, and this substituent may contain the alkyl group or the branches, alkyl branches, the means or it may also contain the subordinate functional groups. I mean the functional groups which are less reactive in a given polyfunctional compound. So these prefixes will contain those names and the root, the parent chain structure, and the parent that we know alkane, and then suffix that we'll add at the end. So in this compound, if you see here, so this OH will also behave as a substituent, and CH3 is anyway substituent, it's a branch. And CHO aldehyde is the principal functional group because we know the activity of CHO is more than OH, and this order we have seen earlier. So CHO is more reactive than alcohol. You can see here, so CHO, H, C, double one O, and this is OH. So this is the principal functional group. This is the subordinate or the subsidiary functional group, and this is the alkyl chain or the alkyl branch. So these two will come as a prefix, and that is what the and this is principal functional group, and so we'll identify the principal chain, and the principal chain to find out the longest possible chain, and that should also contain the carbon atom which is part of the functional group if the functional group contains carbon atom. So this is functional group contains carbon atom C double one O and H. So we will start numbering from here 1, 2, 3, 4, and 5. This is the longest possible carbon chain, and this carbon chain also contains maximum number of branches. If you see, if you go 1, 2, 3, 4, so only 4 carbon atoms and it will have only one branch. But if you go this way, 5 carbon atoms are there and it contains 2 branches. So this branch is there as a subsidiary or the subordinate functional group. And so it will be what will be 1, 2, 3, 4, the 4 hydroxy, 3 methyl, and why hydroxy first? Because H comes before M in alphabetical order. So hydroxy will write first. So 4 hydroxy, 3 methyl, and then how many carbon atoms are there? 5. So pentane, the parent structure, main chain, or if it contains cycles, so it will be for the cyclopentane if it was the cyclic pentane, but it is not cyclic pentane, it's the linear pentane. So it's a pentane and Al that we add for the CHO functional group Al. And since A is a vowel and pentane E ends, E is also a vowel, we do not write two vowels continuously, and so that E is omitted. So it is pentanol. So 4 hydroxy 3 methyl pentanol. This is the name of this compound. And to identify different functional groups and their structure, we'll see this table first. So alkene, what we know earlier, we have also seen carbon double bond. It is alkene, and example you can see here ethene C2H4. So this C double bond C, and this is the structure of ethene, and double bond carbon double bond, and this double bond you one can also add one CH3 group here. The propene is also an example of alkene. And what do we know? The name of this is as we have written alkane, or the alkane if there was no carbon double bond, it was ethane with the 2 carbon atoms C2H6 is ethane. So H is the uh, this numerical root, and this the numerical prefix, and with the numerical prefix we add ane for the saturated hydrocarbon, and we add ene for unsaturated hydrocarbon. So ene we have added here. So it is ethene, the IUPAC name. Similarly, if it is CH3, CH, double bond CH2, CH3, CH double bond CH2, then we will call it propene because three carbon atoms are there and three carbon for this numerical prefix will be prop. And then the ENE group is there, then we remove ANE from the propane and we add ENE. So it will be propene. Then there might be four carbon atoms in that case, but what will happen if the four carbon atoms are there? Suppose C, C, C. So this double bond can be at the terminus between first and second carbon atom or between second and third carbon atoms. Again, if you see third to fourth carbon atom, so then the numbering will start from this side. And so first between first and second and third or fourth, they are same, structurally same. So there is no third and fourth, no double bond between third and fourth carbon in butene or means the alkene containing four carbon atoms. So there is only two possibility of alkene having four carbon atoms and only one double bond, and that would be one, the double bond is from the first carbon between first and second carbon or between second and third carbon. And that case what will happen if there is possibility and if the carbon double bond position is changing, so this is also called a position isomers that we call. And that case if the position isomers are possible, then we'll show also the position of the double bond. In this case there is no possibility of having any position isomers because there are only two carbon atoms and double bond between will be between only these two carbon atoms. So there is no position isomers. So the position of this double bond we have not shown because the two carbon atoms we can also number it as first and second carbon atom and we can call it H1E, but we do not write H1E because there is no position isomer possible for this compound. Similarly, for the CH3 CH double bond CH2, as I have said earlier, propene, this is also propene because the numbering you will start always towards the functional group to give the functional group the lowest possible number. So numbering you will always start from the carbon containing double bond. So first, second and the third carbon will be the saturated carbon or the carbon, the tetrahedral carbon atom having CH3 group. So it is also there is no position isomer. You just change the double bonds positions and then the numbering will start from the left. So it will become CH2 CH CH3. So then the numbering will start from the left side. First carbon that will become first carbon. This is again propene. So the propene, the name I have said, but in the case of butene, you have to write but one in or but two in. There are two compounds, two position isomers that are possible in that case. Now let's see alkyne. Alkyne means at least one triple bond is there. These things we have seen between two carbon atoms. So that is why this INE word is this suffix is added. And the simplest example of alkyne is acetylene, or its IUPAC name of acetylene is ethine. So two carbon atoms and for two carbon atoms we know the numerical prefix eth, ETH, and YNE we add because of the triple bond, so it is ethine. And then the alcohol functional group. The alcohol functional group ROH. We know OH group, so there is O and H bond, and this OC bond. There is a carbon atom in this alkyl group, so there is OC and OH bonds, and so it is alcohol. And you can see the examples here in this compound is CH3 CH2OH, and this is how it is connected. As in the case of water molecule, we know it gets bent structure. Similarly, alcohol, what happens in the water molecule? One of the hydrogen we have substituted one of the hydrogen with alkyl group. It's a group containing at least carbon atom, hydrocarbon. But the alkyl group, I hope you understand this. The alkyl group, then the such compounds are alcohol. So the geometry at this oxygen will be the same as we have seen in the case of water. This is still sp3 hybridized and two lone pairs as we see in the case of water molecules. So two lone pairs will also be there in alcohol. So two lone pairs at oxygen will be there, and so its geometry is bent at the oxygen atom that you can see here. And this contains one and two carbon atoms, and numbering, as we have seen, numbering will start from the carbon, so that the carbon atom containing functional group gets lowest number. So this OH is a functional group and this carbon contains this OH functional group. So numbering will start from this and this. What, although the numbering is not important in this case. Why? Because if you just remove this OH group and add it here, the numbering will start from here. So there is no position isomer. This is also position one from this end, and from this end this is position, this one is position one. So there is no possibility of position isomers. So this numbering is not important in this case. And this compound we call as ethanol. And if the compound contains three carbon atoms and one OH group, and three carbon atoms is CH, suppose it is propane, CH3, CH2, CH3. Now one hydrogen we can at the of the CH3, any of the CH3 group we can change, replace with OH group, and then this compound will be the alcohol. But what we see, any of the CH3 group we will replace, you will not see any change. So they are not position isomers. But what happens if I change the position second, means the one of the hydrogen of the CH2 group, the middle carbon atom, then you can see the numbering will change. So in that case, it is second number 1, 2, 3. However, if you just change the from the left side, you do the numbering 1, 2, 3. If what does it mean? If you just change the side of the numbering, and you will see the similar positions in those cases without any branching. So you can see this, there is no position isomers. This isomerism we'll see in more details from the next class, and you will get a better feel of the position isomers. And if in the case, suppose the propane three carbon atoms are there and the OH group is at the terminus, any of the terminus, then it will be propane 1 all. And if the OH group is at the middle carbon, then it will be propane 2 all, because in this case, with the three carbon atoms, we see the possibility of position isomers. And then the ether we see ROR, means the O oxygen atom is there, in the water, two hydrogen atoms are there. And if you replace both the hydrogen atoms with the alkyl group, then with the functional group that we call is, or the organic compound we call as ether. So this is the ether as the organic compound. And so this R means the carbon atom, it contains carbon atoms alkyl group, and this R prime also contains carbon atom. So this is another alkyl group, and in middle is oxygen atom. And as you see that we have not changed anything at the oxygen atom other than the hydrogen atom with which it was connected, and that hydrogen atom, so what we see, it also contains two lone pairs. Like in the water contains two lone pairs, and the alcohol oxygen also contains two lone pair, and oxygen atom in ether also contains two lone pair. So it will also have a band structure, as you can see here. The two lone pairs are located at this side. So this example is C2H5 twice O. This is diethyl ether. This is ethyl and this is ethyl. This is a common name that we have written here. So this is diethyl and ether. And the IUPAC name what we write, this group we call RO group we call as alkoxy. So what we see, we first see the number of carbon atoms in both the alkyl groups. The alkyl groups which contains larger or higher number of carbon atoms, that we consider as the main chain, and the other O and the oxygen with the other alkyl group that which contains a smaller alkyl group, we consider the alkoxy group. But since both the alkyl group here are, it contains only two carbon atoms, so we can consider any one as a parent chain and any one other as a substituent. So if you consider this as, so this is ethoxy. Alkoxy means it's the place of alk. We know the root, the numerical prefix we add. So this will become ethoxy, and this is anyway ethane. So the IUPAC name of this compound will be ethoxy ethane. And these things we'll see. Let me, my focus here is only to show you how, what will be the structure of the functional group. The aldehyde we know RCHO, we write usually as CHO, but this CHO means this C double bond O and H. And this oxygen also contains two lone pairs, because there is only two bonds here. So oxygen atoms usually know in compound contain two lone pairs, so it will also have two lone pairs. And the structure of this compound, 3D structure, is shown here. So this will be CH3 and a C double bond O and H. This is hydrogen. This is CH3. So this is aldehyde, and it's Al we write as a functional group, the ethanol. So now the ketone. The ketone, what we say, if you in the this aldehyde group, this H was there. If you replace this H with another carbon alkyl group which contains carbon atom, so this will become ketone. So what do we see here? That this group, the carbon double bond O is called carbonyl group. C double bond O is carbonyl group, and any double bond O is called oxo group. So this is carbon oxo is carbonyl group. There might be iron oxo, Fe double bond O, it's iron oxo, Cu double bond O, it's a copper oxo. So this is oxo compound. You should remember this oxo name. If this double bond O, this representation only is called oxo, and with the C double bond O, this is called carbonyl. So this is a carbonyl group, and only this O having double bond is called oxo group. So if this carbonyl group is attached to one hydrogen and one carbon atom in a given organic compound, the functional group is aldehyde. But if this carbonyl group is connected to two different carbon atoms, then it is called the functional group is ketone. And this is what we see. This is C double bond of carbonyl, although we write in this way, but what we know the tetravalency of carbon. So tetravalency of this carbon is connected with the single bond with this carbon and single bond with this carbon. It means carbon should have double bond with the oxygen, and anyway we also know oxygen makes double bond with any single atom if only one atom is there. So oxygen requires double bond to complete its octet. So this carbon double bond, oh, this we know, and this is the structure, and this is the ethyl group CH2CH3. So this is ketone, and the ketone its name is written as ONE, and the common name is what? This is methyl, and this is ethyl CH2CH3. So we write methyl ethyl ketone. So methyl, ethyl ketone, and a methyl we are writing less number of carbon atoms first, and ethyl ketone. You can also write ethyl methyl ketone, and you can easily write this name as well. So this is a common name. Then the functional group is carboxylic acid. Only some important functional groups I have shown here only. Now this functional group carboxylic acid R C double bond O. This carbonyl group is there. And now in the case of this aldehyde, you see this was aldehyde. And if between this carbon and this hydrogen, if you add one oxygen atom, or this is what we call the hydroxyl group. OH group is also called hydroxyl group. This OH group. So if the hydroxyl group is connected to carbonyl atom, carbonyl carbon, this is a carbonyl carbon, the carbonyl group, and anyway this hydroxyl group is connected only to the carbonyl carbon, because carbon is the only atom which can expand its valency, and its valency is not expand it, its valency is 4, so it can have more than two valencies. And if there is only carbon double bond hole, then only we call it as a carbonyl group. If the carbon single bond hole, it is not carbonyl group. Please remember, carbon C double bond hole is a carbonyl group, and this is called carbonyl carbon. And this one can also call it a carbonyl oxygen. Usually we call it a oxo atom. So this, if in a given compound a carbonyl group is connected to hydroxyl group as well as one alkyl group, or means another carbon atom, then the functional group is carboxylic acid. Carboxylic acid, and the example is CH3COOH. So if R is CH3 and the COOH, CH3COH, and the structure you see here CH, one H here, one H here, CH3, and C double bond O, and this is O and H, and this we call acid, and it depends on the number of carbon atom. Acetic, this is acetic acid. Common name of this compound we know is acetic acid. And this ester, this is the ester. Then the functional group what we see, if this OH is the hydrogen of carboxylic acid, the carbox, this is called carboxylic acid group C double OH. If the carboxyl hydrogen of carboxylic acid group C double OH is replaced with another alkyl group, means the group contains carbon atom, means oxygen, this alkoxy group hydrogen of this is connected to another carbon atom, then we call this functional group the ester. Or if this OH group of this is replaced with any halide or any halogen, then we call it the oil halide or carboxylic acid halide. Or if, but we can also, if this one OH is replaced with NH2 group, then this functional group is amide. The structures that we have already seen. Now let us see how one can also write the IUPAC name of such compounds. So some examples, the basic examples we will only see. The alkanes we know, simple their name, and the alkenes we have also seen. And as I have said in the case of butene, see the ethene and propene I have already said. In the case of butene, you can have this double bond here between first and second carbon atom, or you can also have this double bond between this and this carbon atom. If you put this carbon atom between this and this carbon, this double bond between this and this carbon, then the numbering will start from this side. Again, so this position and this position are equivalent positions. So this position and this position are equivalent positions. and so you don't see in this case any position isomer, but the position isomer is because this double bond can be between second and third carbon atom, and so this position isomer and the numbering will start from here 1, 2, 3, 4. So this is but, and this we write but 1 in. So but 1 in. And the case of alkyne, we have also seen the example IUPAC nomenclature. The suffix you see, the suffix we write ene for alkene, ane for alkanes, and ane alkanes we have already seen the numerical prefix, then suffix ane. So An is for the saturated hydrocarbons and Ene for the hydrocarbons containing double bond. So this is a suffix, and Yne, ine, for hydrocarbons containing a triple bond. And so Yne with that we write for the triple bond, and that you can see here this CH triple bond C, CH2, CH3. One can also have this triple bond between this and this carbon atom, the second and third the carbon atom. So it can be CH3, C, triple bond C, CH3. And so we can see two different isomers, and those isomers are only because of the position of the triple bond, then they are position isomers. And so we show the position of the triple bond here in this compound, and the numbering will start with the longest chain is this. Numbering will be started from here, so that this functional group gets the lowest possible number. So this is 1, 2, 3, 4. So this will be but 4, the numerical prefix will be but, and Yne will be for the ion triple bond, and the position of the triple bond has to be shown, and so this triple bond is at the first carbon, so will so after the first carbon, so will so it is but 1 ion. So the name of this compound will be but 1 ion. Now the arenes, we know this is a benzene, and the substituted benzenes name we will see how one can write the IUPAC name of substituted benzenes. So the arenes, you see the example benzene, and this name benzene itself we consider as a name or a suffix for any compound, and there is no any other suffix for this compound. So halides, now halides we know an alkyl halides, and these halides could be chlorine, chromine, bromine, and iodine atoms attached to an alkane. And so if the hydrogen atom is replaced with any one of these halide atoms, then we call such compounds as alkyl halides. And the IUPAC name, in the writing IUPAC name of alkyl halides, there is no suffix, but we add halo as a prefix. Halo means this halo will be written before as a prefix for this by writing IUPAC name of any compound containing these halide atoms. So if you see this example CH3 CH2 twice, means this is CH3 CH2 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 Br. So what we see, four carbon atoms, one, and this CH2 group is 2, 2, 3, and the 4. Four carbon atoms, and at the and this Br group is attached at the terminus. And so this Br can be at this position. We can also put at the second position. And if we put at the third position, then the numbering will start from this side. So what will happen? We'll number this compound in such a way so that the Br, the carbon atom which contains Br group, should have lowest possible number. So this is the carbon atom. So we'll start numbering from this end. And the numbering will always start from one end, so that the max. So this 1, 2, 3, and 4. So what we see, the this bromine as a prefix we will write, and for bromine it is bromo, for fluorine it is fluoro. So X, for halides it is halo, the common name we have written. So for fluorine it is fluoro, chlorine it is chloro. So it will, that is how we distinguish these different halide groups: bromine, bromo, iodine, iodo. So similarly we write, so since it is bromine, so we will write it as a bromo, and the bromine is at the first position, so one bromo, and then the four carbon atoms butane. So this bromo is used only as a prefix, one bromo butane is the IUPAC name of this compound. Now what can I do? This atom, I can make this atom CH3, and the Br I can put at the second carbon atom, and the second means another carbon atom, maybe after the carbon atom which is directly linked to this carbon atom. Then the numbering will again start from the same this carbon atom only, because in the numbering we have to consider the longest carbon chain. So this carbon atom will have number 1, and the second carbon atom will, which contains bromine, will get the second position, then the third and fourth. in that case we will write 2-bromobutane. So there is a position isomer for this compound, possibility of position isomer. So suppose if in that direction, if the compound is from the right to left, CH3, CH2, then CHBr, CH3. If in that case, then the numbering will start from the left. So this carbon will be first, and this second carbon will be which contains bromine from the left hand side. So that compound will again be 2-bromobutane, and so that compound is what the position isomer of this compound. So you either you put this bromine at this carbon atoms from the right hand side at the second position, or from the left hand side at the second position. They are same compound. Or if you put this bromine at the first carbon atom from the right hand side, or at the first carbon atom from the left hand side at this carbon atom, they are the same organic compound, and their name is 1-bromobutane. Now we see alcohol. Alcohol, the OH group we have just seen, and the alcohol, if it is a subsidiary functional group, so this alcohol can be a principal functional group, and it can also be a subsidiary functional group. This halides we always consider as subsidiary functional group. So we always consider as a branch, or as a branch or the substituent. But for the alcohols, we consider this alcohol as a principal functional group, and if it is the most reactive functional group, and if this alcohol is not the most reactive functional group in the given compound, we'll consider it as a substituent or the subordinate functional group. And if alcohol OH group, the hydroxyl group, is there in the compound as a subordinate functional group, we write its name in the prefix as a prefix, and the prefix that we use for OH is hydroxy. So for its position we write hydroxy, and examples we will see later on. And if it is the principal functional group, we will write OL. So if you see this compound CH3, from CH3, CH2, CHOH, then CH3. So this OH group is attached to this carbon atom. So this carbon atom, then again what we'll do, we'll number this carbon atom, and numbering will start from one of the end. So we'll start from one end, one, then this carbon atom 2, 3, 4. We cannot start numbering from this end, because in that case this carbon atom containing OH hydroxyl group will get third position. So this way the numbering will be the wrong one. So we'll do the numbering of this carbon chain, the longest carbon chain, from the right hand side to left hand side in this direction. So 1, 2, 3, 4, and the numerical prefix will be what? But, because this compound contains 4 carbon atoms, and for but it should be butane. So butane, and the 2-ol, and this OL we write it as a suffix, because OH group is the principal functional group. There is no other functional group for other than this OH. So this is principal functional group, and the position of OH group we have shown because it is at the second carbon. So we write butane 2-ol, all. Butane 2-ol, and why E we have removed here? Because E and O, they are vowel. So the first vowel we remove. So E we have removed. So butane, it was butane OL. So it could be propanol, ethanol. We have, as we have seen earlier, this is ethanol, because there is no possibility of position isomer. So this is ethanol, and E we have also removed here. In this case, we have also removed in writing APAC name of this compound. Then comes the aldehyde, the CHO, and we know it's a C double bond O and then H, and this carbon is connected to another alkyl group, means the carbon chain. And so if this is there, this CHO group is there in the compound as a subsidiary functional group, this is not the principal functional group, not the primary or the principal reactive center of the compound, then we consider in writing their name, the name of the compound, we consider it as a prefix, and we write its name as a oxo or the formyl. Oxo for, as I have said, for the double bond. If we have to just write the position of the double bond O, then we write oxo, means the carbon atom of the CHO is considered into the numbering. If that is there, then we write oxo. And if CHO group we consider it as a entire CHO group as a substituent, then we write the word prefix formyl. So if double bond O is considered only as a substituent, then we write oxo, and a similar thing we can do for the ketones as well, because C double bond O is also there, and if it is a prefix, used as a prefix, it is oxo. However, the formyl we use formyl if this entire CHO group with its carbon atom is considered as a is considered as a substituent or the subsidiary functional group. So the carbon atom of the CHO is not considered in the numbering, then it is formyl. And if it is CHO group is there as a principal functional group, so we write AL. So example you see here CH3, CH2, CH2, CHO. The numbering will start this functional group contains carbon atoms. So as I said earlier, if the functional group contains carbon atoms, so usually we do the numbering including and from start the numbering from that carbon atom which contains the functional group. So the numbering will start from CHO. There is no other way to start numbering for this compound. So we'll write this start numbering from here. 1, 2, 3, 4 because two CH2 groups are there. And since we start numbering from the first carbon atom, from the carbon atoms which contains the which is part of the functional group itself, then in that case there is no possibility of the position isomers. So we won't show the position of CHO group. We won't write all the times one all. So this is butanol. So if what else one can write but one all. If this is there at the second position, then other compound like what I meant to say this is CH3, CH2, CH3 and this CHO, CH3, CH, CH3 and this CHO is at the second position, second carbon atom. Then the numbering will start from this end, from that CHO and there will be one substituent, one CH3 group will be as a branch. So this CHO numbering always contains this carbon atom of the CHO group and so there is no possibility of position isomers with this name and so we don't write position of this. So it is butanol, propanol, pentanol, hexanol. It will always be like this. Now, if the branches are there, suppose if it is here and suppose at this position, where is at the second position, second carbon atom from this side. So CH3, CH2, CH, and if there is CH3 branch here and CHO, then we will write the name of this compound as 2-methyl butanol. So now the ketone C double bond O, if it is as a subsidiary functional group, we write it as a prefix, then the IUPAC group prefix for the C double bond O group. For ketones is oxo, and for it is actually for the double bond O oxo. This double bond O is called oxo group, and the carbon is part of the numbering in because it is there inside the chain, so it will always be part of the numbering. And this double bond O is only something which one can consider as substituent or the uh, a branch, and so the oxo is used as a IUPAC group prefix, and IUPAC group suffix for this ketone group is ONE. ONE, one, it is not one, it is read as on. So if you see this compound CH3, CO, CH2, CH3. So in this case, although this functional group contains carbon atom, but its numbering will not start from this end. Actually, will start numbering only from any end. The CHO group, as we know, CHO group is at the terminus always of any carbon chain because at the other side it contains hydrogen or maybe the double bond O. So the carbon in atom it will be like start from here. Even similar thing we see in the case of carboxylic acid, carboxylates because this is the carbon atom, not this are not carbon atom. So this will be at the end, at the terminus. This C at the end, esters. If you consider this part or this acyl halide, this is the at the end only. The amide also it will be at the end, the carbon atom. So anyway, this uh, ketone is will always be in the middle of double bond O group will always be in the middle of the carbon chain. This is what this ketone functional group is defined that we know. So this CH numbering will start from this carbon atom so that this carbon atom gets lowest possible number. So if we start numbering from this side, it will get third position, this carbon atom. If you do it from this side, it will get second position. So 1, 2, 3, 4 and this so we'll call this name is but for the numerical prefix 2 on. So but 2 on or butanone you can also write this compound if you because this C double bond O if it comes at this position it will be aldehyde. So what we see in this case also this there is no possibility of the position isomer so we may not need to write 2. or identifies this carbonyl group as means this CO group is at the second position. But if you write, usually one may get confused with the aldehyde, so we just write but2-one. So sorry, butane 2-one, butane 2-one. But this is for the this we write for the parent structure or the main chain for this butane. So E we have removed here again because O is the vowel. So E we have removed in this case. Now functional group C, nitrile, C triple bond N. If it is there as a substituent, we write as a cyano. So we represent it as a cyano group, and if it is there as a principal functional group, and then we write its name as a nitrile. So the suffix nitrile is used to write the name of the compounds containing CN group as a principal functional group. So IUPAC group prefix for the CN group is cyano, and IUPAC group suffix for the CN group is nitrile. So if this compounds, let's see, and this nitrile also contains a carbon atom. So the numbering will start from this carbon atom always. So 1, 2, 3, 4, 5 in this compound. So 5 carbon atoms. So for 5 carbon atoms, pentane and the nitrile. So it is pentane nitrile because this numbering will all is starting from this position always. So will not show the position of this carbon atom. So it is pentane nitrile. And this pentane nitrile means while writing this structure of the pentane, if someone says pentane nitrile or butane nitrile. Butane nitrile, when you write, you should understand that at the last carbon atom, at one of the terminus, whether left or right, should is actually the nitrile group. Then we see the thiol. If a compound contains SH group, we know H2S, hydrogen sulfide. If the hydrogen, one of the hydrogen of the H2S hydrogen sulfide is replaced with the alkyl group, or if oxygen atom of alcohol is replaced with the sulfur atom, and sulfur atom we know it is below oxygen, it is a part of the same group of the oxygen. So we call such a functional group as thiol. So thiol is thio word we use, and the OL we write for the alcohol, so it is thio. So or the thio alcohol functional group, it is the thio. So this we write the if it is there as a subsidiary functional group, we write it as a mercapto, and if it is there as a principal functional group, then with the suffix that we write IPSC group suffix as a thiol, and IPSC group prefix for SH group is mercapto. And the example you see here, CH3CH2SS and CH3CH2SS numbering is not important in this case. So as we know ethane also, we can write this name of this compound as ethane, one two carbon atoms, and this group is for the thiol, so it is ethane thiol. And ethane thiol E we have not removed here because this T of the thiol is not a vowel, so we write it as ethane thiol. So ethane we write complete and then thiol. Now the ethers, and ethers we have seen oxygen atoms connected to two carbon atoms and two carbon, or otherwise both the hydrogens of water is replaced with two different alkyl groups. And so, and usually this OR group, they are always considered as a substituent. They are not considered OR group as a principal functional group. In naming the IUPAC or writing the IUPAC name of the ethers, and so we consider it is always a mercapto or the prefix, it is always used as a IUPAC group prefix, and the IUPAC group prefix for this ethers is alkoxy. And the what method we follow to write the name of this compound, as I have said earlier, is we'll see which carbon atom is longest that is attached to oxygen atom. So out of two alkyl groups, the one which contains the larger number of carbon atoms is considered as a principal chain, and the other chain with the lower number of carbon atoms, which O group, oxygen atom, is called alkoxy. So since this is what we have seen, both are ethyl group, CH3, CH2 group. So anyone can consider. So this if you consider as ethoxy, so this will become ethoxy ethane. If this was suppose if this was CH3 O CH2 CH3, then what we call CH3O we will consider as a substituent, and the carbon atom which contains more number, the chain alkyl group which contains more number of carbon atoms, that is C ethyl group CH2 CH3 is the main chain. So the numbering will start from here 1 2, anyway one can do, and this is actually the methoxy. For meth, alkoxy, as we said, alkoxy alkane, alk is the numerical prefix, and so if it's a numerical prefix, we change for two carbon atoms ethoxy, one carbon atom methoxy, three carbon atom propoxy, like this one can write. So this if this was CH3O CH2 CH3, it was methoxyethane. If it is CH3O CH2 CH2 CH3, then it is methoxypropane. And if the compound is CH3 CH2O CH2 CH2 CH3, then the compound is ethoxypropane. The propane, the larger number alkyl group, is considered as the principal chain in that case. There are also way of, to write IUPAC name when you also consider oxygen as a part of the numbering, but that name we usually see for the epoxy group and the cycle. These names are there, but that is not part of your syllabus, so we will not go into that. Now let's look at the carboxylic acid. The carboxylic acid, the group prefix for the carboxylic acid, and when we use group prefix, when the carboxylic acid is not the principal functional group, and that the name is carboxy. For carboxylic acid, name is carboxy as a prefix for this carboxylic acid. But if the carboxylic acid is the principal functional group, then we write the suffix for this, and the suffix is oic acid, OIC acid. And you see here this O is also a vowel, so the E of the alkane, the last E of the alkane, the ending E will be removed in that case. Now let's see the example of this is CH3 CH2 COOH. So this functional group also contains carbon atoms, and this is the terminal carbon atom. So the numbering will start from this carbon atom. So 1, 2, 3 and the 4. So this is butane and oic acid for this COOH group, and since COOH group, it is the first carbon of this entire thing, so we will not show the position of it. So it is butanoic acid. So this, since numbering has started from this, so the position of this acid is not shown. And if you are using oic acid, it means it is already there that the numbering has is started from the carbon atom which is part of the functional group or COOH group. So numbering is started from the COOH group if you are writing oic acid as a IUPAC name. Some people, earlier people were also saying it as a propane carboxylic acid. So this three numbering will start from the this way. So second carbon, so not this carbon. So 1, 2, 3. So this becomes propane, and in that case you have to show the position isomers propane 1 carboxylic acid, because this COOH group can be attached to the second carbon atom as well. So anyway, usually this is the one the mostly followed IUPAC name. So we write it as a butanoic acid. Now the carboxylate ions. The carboxylate ions, usually ions, if ions are there, their reactivity will be highest. So ions we write OAT, and this will always be used as a suffix. There will be no prefix for this because it will be the highest reactive part of the organic compound. So that if any OHC minus group is there, it means this is the principal functional group, and it will always use OAT or the group suffix for this anion. And for example, if you see CH3, CH2, CH2, COO, Na, and the COONA is COO minus and Na. So usually as we write the name of any ionic compound like sodium chloride, we will first write the name of cation and the name of anion. So we'll write here as well the name of cation first. So name of cation will be sodium, and then this is contains 4 carbon atoms, and this is O8 we write. So butane, the numerical prefix, and OAT we add. So butanoate, and E we will remove here again because this is a vowel. So E of the butane will be removed. So this is sodium butanoate. Now the esters we know the hydrogen of carboxylic acid is replaced with alkyl group and this R group, and so if the ester is there as a subsidiary functional group, so this is called as alkoxycarbonyl. So we call it as alkoxycarbonyl. So this group as alkoxy group OR, and this is carbonyl. So if this is COO CH3, then we call it a methoxycarbonyl. If this was COOC2H5, so this is a ethyl group. So ethyl with O becomes ethoxy, as we have seen in the case of ethos. So this will become ethoxy, this is the carbon. So ethoxy carbon. And if this ester is the principal functional group, we will write it as OATE as we see for this anion. So OATE means what? Then we see some prefixes will be there. So this is what alkoxy. So anyways, this group and this C double O group we consider as the one functional group, and this R as a substituent we consider in writing name of esters. So if you see this compound CH3, CH2, COOCH3, so as you see up to here, as we saw in the case of anion, so up to here we can consider name as anion or the carboxylate ion, or then CH3 group we will consider after the O whatever it is a methyl group. So this is methyl propionate. So this methyl and 1, 2, 3. So propane and O8, propanoate. And suppose if it was CH3, CH2, COO, C2H5, then it was ethyl propanoate. And if this compound was CH3, CH2, CH2, C double O, CH3, then we will call it as a methyl butanoate, because this contains, including this carbon atom, contains 4 carbon atoms, so it will become butanoate, and the numbering will start from this 1, 2, 3. So if there any number, any branching are there in this compound, so those branches will be shown as a prefix for this compound. These are very simple examples. We'll see a bit complex examples little later on. So the simple, you just to learn how one can write just the names of very simple compounds. I will see the bit complications as we proceed further. Now the acyl halides, the COX. Under COX, the functional group we know this X can be AFClBri. This is a halide. And C. So what we have done, this OH group, the hydroxyl group of the carboxylic acid is replaced with the X, the halide. So this is called acyl halide. This is a compound functional group is acyl halide. And in the writing IUPAC name, the group IUPAC group suffix for this acyl halides are oil halide. So this for this group we call oil halide, COX. And this oil halide contains this carbon. So entire COX is called oil halide. The carbonyl, you know, this is carbonyl, but from the carbonyl we have considered oil, not only this part, and this rest of the things we consider as we have seen earlier. And if this was the acyl halide was there as a subsidiary functional group, then we call this group as a halocarbonyl. So this is halo and this is carbonyl. This is a halo group. If it is fluorocarbonyl, chlorocarbonyl, bromocarbonyl, iodocarbonyl, and this if this is the IUPAC used as IUPAC group suffix. So if this was COF, then we call oil fluoride. If it was COCl, oil chloride. If it was COBr, oil bromide, oil iodide for iodine. Now let's see this example: CH3, CH2, CH2, COCl. So the numbering will again start from this carbon atom 1, 2, 3, 4. This compound also contains 4 carbon atoms. So it will be butanoyl. Butane from the Ne will remove because there is also a vowel. So butane, and then oil will be added and chloride. So you see there is a gap between eel and halide. So butanoyl chloride. Here also there is a gap between these two, methyl propanoate, sodium butanoate, butanoic acid. Other than in other cases we have not seen any gap, any space between two letters. Here also there is no space, although it appears as a space in this case. Now let's see the amines. Amines, we know amines could be primary, secondary, or tertiary. Primary is when one hydrogen of ammonia is replaced with one alkyl group. It is primary amine. If the two hydrogens of ammonia is replaced with two different alkyl groups of the same alkyl group, means two alkyl groups, then it is secondary amine. If all the three hydrogens of ammonia is replaced with three alkyl groups, then we call it as a tertiary amines. And the tertiary amines, all these amines, what we write their name, if they are the subordinate functional group, means if they behave as a substituent in a given compound, we use amino as a prefix for them to represent their position, their name, and we use if they are the principal functional group, we use suffix amine, AMINE. And amino, you just see the change at the last, this amine, the suffix on amino prefix. And let's see the name of this compound. One CH3, CH, NH2, CH2, CH3. So in this case, one can start numbering from the right hand side. If you start numbering from right hand side, it will be 1, 2, 3, 4. So the third carbon contains the NH2 group, the functional group, and that is not right. If you start from this way, the second carbon contains NH2 group. So this way the numbering will be followed. So from left hand side to right hand side. So the name of this 1, 2, 3, 4. Then four carbon atoms will call it butane, and this is the principal functional group, only functional group in this compound. And then the position of NH2 group is to be shown here, butane 2 amine. And why? Because this NH2 group can also be here. One can replace this hydrogen of CH3, one of the hydrogen of the CH3 group, with the NH2 group, and then add that hydrogen here. So there, if it was NH2, CH2, 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 CH3, then this compound's name will be, so since NH2 is at the first carbon and butane 1 amine. Now let's see amides. Amide CONH2. CONH2 is the primary amide. We can also see primary, secondary, and tertiary amide. And the CONHR is secondary amide. A CONR2 is tertiary amide. So all the amides you can see here. So primary amide is what? If one this ammonia, or you see one, if this OH group, OH group of carboxylic acid, or the acid group, is replaced with the NH2 group, or the primary amine. You can see the primary amine. If OH hydroxyl is in the place of hydroxyl, there is a primary amine, then we call the functional group as amide. If in the place of hydroxyl group, if there is a secondary amine, NH, and you know there is a carbon, so because one is carbon here already, this nitrogen is attached to carbon, this C double bond O, and then carbon. And then if it is if this nitrogen group is connected to two carbon atoms, then it is secondary amide. Here also it is two carbon atoms. This NH group is attached to two carbon atoms, the secondary amine. Here also it is attached to one alkyl group and one carbonyl group. So this is also a carbon atom. So this is secondary amide, and this one is tertiary amide because this is alkyl group. So two alkyl groups here and one carbon atom here. So the nitrogen is connected to three carbon atoms. So this is tertiary amide. And this amide is there as a side chains. If you consider them as a side chains, they are not the principal reactive functional group. Then it will be there. Its name, while naming it, it will be used as a prefix, and IUPAC group prefix for amides is carbamoyl. So carbamoyl, remember these names are important. Carbamoyl as a prefix, and amide are the is used as a suffix, IUPAC group suffix for all the amides, whether that is primary, secondary, or tertiary. As we have seen, amine for the primary, secondary, tertiary, all the amines. Similarly, we use amide for all the amides, and the carbamoyl we use as a prefix for amide group. And the prefix, when we will use prefix, when this functional group is not the principal functional group of the organic compound, means in that organic compound there is another functional group which is more reactive than this compound. Then if you, let's see this example. So CH3, CH2, CH2, CONH2. Again, in this case, the numbering will start from here, 1, 2, 3, 4. And this is the four carbon atom, the four carbon atom butane, and A is also a vowel. So E of the butane we will remove. So butane, and then we, for this group, CONH2 group, will add amide. So this will be butanamide. So this is butanamide, the name of this compound. Now the nitro compounds. Nitro compounds like halides, alkyl halides, they are also considered as only the substituent, and their name will always be considered as a prefix. So nitro compounds, so we'll use only as a prefix. It will not never go as a suffix, although this is a functional group. So one nitro, these are just rules that is given by IUPAC, and we have to follow and remember these rules. So these rules are to be remembered. We may try to find out some ways to remember this so easily, like as we are trying to do this. So this is nitro is always considered as a prefix, not as a suffix. We don't have any suffix for this. So this will always be a its name will always be written as a substituent. Now if you see the CH3, CH2, 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 NO2. So 3 CH2 groups and 1 CH3 means this NO2 is attached to the last carbon atom on the right hand side. And since we know this last carbon atom and numbering will be done from the right hand side to left hand side to give the carbon atom that is attached to NO2 group always number, so 1 2 3. But however we see this NO2 group can be attached to the second carbon atom from the right hand side, so there will be possibility of position isomer. So the position of this NO2 group will be shown. So this is nitro, and since nitro, at what position this nitro group is attached to the first position, so it will be 1 nitro, and then the butane for the to represent this compound contains 4 carbon atoms. Now this sulfonic acid, we know sulfonic acid SO3H group, and if the sulfonic acid SO3H group is there as a subordinate functional group, to use sulfo, and the sulfonic acid, the sulfonic acid functional group, whatever it is there, as a suffix, IUPAC group suffix. So this compound CH3SO3H, and this CH3 is what? So this is methyl sulfonic acid. We call this as methyl sulfonic acid. It is not methane sulfonic acid, it's a methyl sulfonic acid that is given here. So usually, now let's see these things we have already seen. Now let's see a few more examples. So in the case of polyfunctional compounds and other rules, in the case of polyfunctional compounds, one of the functional group is chosen as the principal functional group, and the compound is then named on that basis. And what is that basis? One of the principal group is one of the functional group as a principal functional group. And what is that principal functional group? The base is determined based on the reactivity, and reactivity, because it is the chemical, it is the experimental thing. So people had already determined the periodicity order based on the experimental results, and it is already given to us. So the remaining functional group, which is the subordinate functional group, are named as substituent using the appropriate prefixes. And what will the prefixes for each functional group? The prefixes IUPAC group prefix we have already seen in that table. Only we have to remember is the preference order for differentiation. So this COH, the functional group we start, but before even COOH, there is COO minus. As you can see in this group here, the OA, the carboxylate anion. The carboxylate anion, if it is there, and usually if the carboxylate anion means this group will only become carboxylate. So usually, so it is COOH group. Then the carboxylic acid, then sulfonic acid. So carboxylic acid is having highest reactivity, then sulfonic acid, then ester. So carboxylic acid, then sulfonic acid, then ester, and after ester, what we see, the acyl halide, and acyl halide or the oil halide, we see the suffix, and then amide, then nitrile, then aldehyde, and then ketones. So what we see, aldehydes are more reactive than ketones, and then alcohols, then amines, and then double bond, and then triple bond you can write. So this is a very important. Carboxylic acid COOH means the OH group, if it is there with the CO group, that is uh, having highest reactivity. And so this is acid, and sulfonic acid is also a strong, is also an acid, so its reactivity comes after the carboxylic acid. Then this hydrogen is replaced with the R group, OR. So this CO the ester, and then halides, and then you see this halide X group replaced with NH2 group. So these are amides. So all the amides comes in this group, the primary, secondary, tertiary amides. And this X, we know X is fluorine, chlorine, bromine, iodine, and then CN, nitrile, and we know the prefix is cyano, and the suffix is nitrile. For the carboxylic acid, it is what? You see the carboxy, and then the suffix is oic acid. And for this, let's see, finish this. Then the CN, then aldehyde, then ketone, then OH, then NH2 group. OH means alcohol, then amines, and this amines means all amines. The primary, secondary, tertiary amines, and then double bond, which is alkene. Thus, a compound containing both an alcohol and a keto group is, if the compound contains alcohol and keto group. So what we see, the keto group is more reactive than alcohol. So this will get more preferences. Then the keto group will be the principal functional group. The principal functional group and OH, the hydroxyl group, will behave now as a substituent only. So what we write the hydroxyl group as a prefix. So one can say it is a hydroxyalkanone. So it will be named as hydroxyalkanone, known ONE for ketone. Since the keto group is preferred over the hydroxyl group, and that order we have got from this thing. And here you have to note that all the R groups, alkyl groups, or the C6H5 group. C6H5 group is called phenyl group. Then all the halogens, fluorine, chlorine, bromine, iodine, or the NO2 group is a nitro group, or the alkoxy group, OR groups. They are all considered as prefix substituents. So these groups are always considered as prefix substituents. And so now another thing is the ending E of the parent alkane is removed when the first letter of the functional group suffix is vowel. So functional group suffix, if it contains first letter vowel, then the E, ending E of the parent alkane will be removed. If that functional group suffix do not contain vowel, then we don't remove it. The examples you can see here, the nitrile, it doesn't contain vowel, so we write pentane is written here nitrile. So pentane nitrile. However, if it contains the suffix of the principal functional group, a vowel, the first letter is vowel, then E is removed in this case. So for all the cases, we do this. Now let's see some examples. And this HOCH2, CH2, 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 CO, CH3. And the name is what, as we have seen earlier. And for this case, so the name is there. So this compound, the numbering will be done from this side. This is the principal functional group, and so the numbering will be from this end. So 1, 2, 3, and 3 carbon atoms. 3 is 6, and this one is 7. So what we see, this OH group will be considered as the prefix substituent, and the prefix substituent, so we then this substituent at the 7th carbon atom. So this will become 7 hydroxy. As you see, if OH group is used as is there, its prefix group prefix is hydroxy, so 7 hydroxy. So 7 hydroxy, and then parent chain name will be heptane because it contains 7 carbon atoms heptane, but E of the heptane will be removed and the ONA will be added. And why 2? Because the positions of CO group we have shown here. This CO group can be at this position as well. So this compound can be CH3, CH2, then CO. So that is why this position of the second this carbonyl group at what position the carbonyl group is there, that is shown. So it is heptane 2 on, and we do not start numbering from this end because this is not the principal functional group. Or we can also not write 2 oxo heptane 7 all because this is not the principal functional group even if the numbering starts from this side. So what happen if we consider this as a substituent, not as a subsidiary functional group, and this is the principal functional group, then we will have to write the position of double bond O. So it will become 2 oxo and then heptane 7 all. But 2 oxo we don't write because it's not the correct way. And why that is so? Because these ketones are having higher reactivity than alcohols. Now let's see another example. This BrCH2CH double bond CH2, and its name will be, the numbering will start from this side again. So 1, 2, 3, and at the third position will be 3 bromo. So this is 3 bromo, then this is prop, and the prop and 1 in. So 3 bromo prop 1 in. So we write the name of this compound as 3 bromo prop 1 in, and we do not write it as a 1 bromo 2 prop 2 in because we cannot start numbering from here 1, 2, 3. We have to give this double bond lowest possible number. And why this double bond lowest possible number? Because this is always considered as a branch, as a prefix substituent. So the numbering will be given to this, the preference will be given to the double bond over this Br or the halide group. The preference, so this double bond, the numbering will start from here. If you start numbering from this side, this will get the second position, so that number in the order will be wrong because the double bond should get preference in the numbering. So numbering will start from this carbon atom. So this is thus becomes 3 bromo prop 1 in. And why prop 1 in? Because Uh, Prop 1, anyway, that you see, prop 1 is not important in my view in this compound. So anyway, now let's see if more than one functional group of the same type are present, their number is indicated by adding di, tri, etc. before the class suffix. In such cases, the full name of the parent alkane is written before the class suffix. For example, I think that two time is over, so I'll just explain this and other things we'll see other examples later on. So if more than one functional group of the same type are present, suppose two OH groups are there, or two NH2 groups are there, or two CO groups are there, carbon ketones are there, or two aldehydes are there in the same compound, or two carboxylic acids are there, these possibilities are there. Then in that case, what will happen? Their numbers is indicated by adding dry, try, etc. Then whatever their number, the functional group, what we do, how many numbers are there? So if it is this OH group, like here two OH groups are there, hydroxyl groups are there, so we'll write it as diol. If two NH2 groups are there, diamine. If two, and so on. So we'll see the name of this compound will be other examples you can similarly do. So CH2OH, CH2OH. So this is ethylene glycol. The common name of this compound is ethylene glycol, but IUPAC name will be 1 and 2. So this is ethane and this position OH groups are at the first and second carbon atom. So 1, 2 diol. This could be this two OH groups. One can write CHOH, then OH, and then CH3. So it will become ethane 1, 1 diol, or and so on. So this is what we write. So we write the full name of the parent alkane is written. So in this case, full name of parent alkane we have written the ethane and this 1, 2 diol. So full name is E is also intact here. So E is used, the full name ethane, and 1, 2 diol, or di we have used for OL. And no, here we have to also note one thing, that the ending minus means ending Ne of the parent alkene has to be dropped in case of compound having more than one double or triple bond. If more than one double or triple bonds are there in a given compound, so the ending Ne of the parent carbon chain will be removed. Like what we are saying, only we have removed if the group suffix or the functional group suffix contains the first letter is vowel. But if we remove Ne if there are more than two double bonds and two triple bonds in a given compound. And in the case if there was only one double one or one triple bond, the Ane we have removed. The examples we have seen earlier here. So this is ethene, even in the IPAC name is ethene. So Ane we have removed. Ane removed and we have written I. But if the compound contains more than one double and triple bond, only Ne is removed, and so we write this compound's name. If you have to write CH2 double bond CH, CH2. So two double bonds are here. So and the numbering can be from any side because the both the sides are equivalent. 1, 2, 3, 4. So double bonds at first and third position, and if you do the numbering from this side, 1, 2, 3, 4, the double bond again will be at the first and third side, so they are same equivalent. So where the four carbon atoms, so it will be buta. So butane, it should be butane, but Ne we have removed. So we will write buta and 1, 3, 1 and 3 diene. So it is the name of IUPAC name of this compound is buta 1, 3 diene. If there was only one double bond or one triple bond, what we have to, we remove Ane and then we add in or ine. If there are more than one double bond or triple bond, then we remove only Ne and we write di or tri-ene. And we remove only E if the functional group suffix contains a vowel, only E. And other examples you can just see. I think I'll finish this. I'll finish this as well, these examples. Now let's see the writing the IUPAC. This is what this is carboxylic acid group C double bond O OH. A carboxylic acid, and here it is ketone. CO. This is another alkyl group. This is another alkyl group. So these the two functional groups are there. One is carboxylic acid, another is ketone. And this priority order, we know carboxylic acid gets higher priority than the ketone, means the carboxylic acids are more reactive than ketones. So carboxylic acid is the principal functional group and the ketone is the subsidiary or the subordinate functional group. And so this the name is the numbering will start from here. So this is the principal functional group. So 1, 2, 3, 4, 5. And for the ketones, as we know, if it is a subordinate functional group, we use prefix for that, and the prefix that we represent only O, double bond O, and we see the oxo group. This double bond O is oxo group, and this oxo group is at the fourth position. So this the name of this compound will be 4-oxo. As we know, 5 carbon atoms are there. So 4-oxo pentane oic acid, and oic acid Ne is removed and oic acid for this. And from this table, how the substituent you can see here, if it is ketones are as a subordinate functional group, means with the prefix substituent that in the oxo, we use oxo name for this. Now let's see this example. In this example, what we see, they are all substituents, the prefix substituent, bromo, chloro, nitro. Then in that case, if the prefix substituents are there, then we will follow the rule, the alphabetical order. And which one should get the alphabetical order? One thing, and alphabetical order, before that alphabetical order, we'll see if we start numbering from one end, from one, which end we start numbering so that this substituent gets lowest number. If we start from this side, we'll get 1, 2, 3, fourth position chloro, fifth position nitro, sixth, seventh position bromo. Now if we start from this end, 1, 2, 1 first position bromo, second, third position nitro, fourth position chloro, and that is why numbering is started from this end. So 1, 2, 3, 4, 5, 6. Now there are all three substituents are there, and to write these three substituents, they are all prefixes. They are all prefix substituents, and to write their name, one thing is the first letter should be, you can just remember the capital letters usually, and so I have just copied it from one of the places, so they have made an error. So anyway, so what is there? The bromo B comes in the alphabetical order first, then chloro comes, and then nitro. So we write 1 bromo, 4 chloro, 3 nitro, 7 carbon atoms, heptane, because this is saturated hydrocarbon. There is no double bond, so it is heptane. So 1 bromo, 4 chloro, 3 nitroheptane. Now this example we know this is a cyclic compound, and this cyclic compound is ketone, and this is hydroxyl group alcohol. Although we know the ketone gets higher purity, so numbering will start from ketone, and this will get the second number. We cannot go this side 1, 2, 3, 4. So in that case, this will get the fifth number. So that numbering is not preferred because the substituents get lowest possible number. So 1, 2, and so 1, 2 other carbons, the total number is 5 are not important. So this will become the parent hydrocarbon is cyclopentane. But what we see it is 2 hydroxy, the second position hydroxyl group is there. So it is 2 hydroxy. So from the hydroxy is the substituent that we use the prefix substitution. So 2 hydroxy and then cyclopentane 1 on. And one we are not showing because as we have said 2 hydroxy, it means the numbering before that the H group is there. So one is not important to write here. If suppose this O was this carbon double bond O was here, and so numbering 1, 2, 3, it will become 3 hydroxy cyclopentanone. So the position showing this position is not important, it's 2 hydroxy pentanone. Now this compound we see is SH. This is mercapto group, and this mercapto group is what? It's the substituent usually. We consider substituent, but this is a ester functional group, and in writing ester functional group, we write this as substituent initially. So this will become ethyl. So this is a ethyl. So this ethyl group we write, if you remember, and now this entire group, and the numbering will start from here 1, 2, 3, 4, and this group also contain another substituent at the fourth position. So this is ethyl. First ethyl we write ethyl ethanoate or alkyl alkanoate, the name of this is written. uh, Esters are written as alkyl alkanoate. You see methyl propanoate. So propanoate, because there is no branching in this case. If the branching is there, so in the propanoate only the branching we will have to show. So this compound, the branching we have to show this, the prefix substituent is there, and SS if it is there as a prefix substituent, and that we know we write mercap to, and the position of SS group has to be shown because this SS group could be here, it could be here. So there are other three places, second or third carbon atom. So we'll write ethyl and then ethyl 4 mercap to, and then after ethyl there we write a space. As you see here also we write a space, we keep a space here in the esters, methyl after alkyl. So this is ethyl, E should be capital letter. There is an error, ethyl 4 mercapto, and then 4 carbon atoms. So for the 4 carbon atoms, what it is butane, and butane E we will remove because O8 we write for this group if it is ester. So O8 for C double bond O. So this is ethyl 4 mercapto butanoate. Now this compound, two functional groups are there, one, two, three, four, five, and as we know, the OH group gets priority over double bond. As you see, sorry, in this priority order, OH group more reactive than the double bond. So OH, the numbering will start from this carbon atom, so that we give the carbon atom containing OH group the lowest number. So one, two, three, four, five. So we'll go from this end, and this from this end. Although we write this ENE, as we know, as a position. So what we write, it is what, one, two, three, four, five, and five it is because paint, and what position in is there, paint and fourth position in. So paint 4 in, and the fourth position double bond is there, paint 4 in, then 1 all. This OH group can be here as well. So the numbering, even if this OH was here, the numbering will still start from the same thing. So the O, the where the OH group is there, that position is to be shown, and so it is paint 4 in 1 all. So people also write is 4 pentanol because we can call it a pentanol, and it's the since in is at the fourth position, 4 pentanol. Although this name is not right, this is the right abbreviation, the pent 4 in 1 all. Because if this OH group was here, how will you differentiate between this? This can also be called as a 4 pentanol. So this one is not a right one. The name which is there in the parenthesis here, this is the right one. So pent 4 in 1 all. Now this compound, and in this compound, as we know, the triple bond gets POC double bond. After the double bond, we can write here the triple bond. Sorry, or alkyne I can write. And so this will get priority as this is the prefix substituent. So 1, 2, 3, 4, 5 we write. This is 5 chloro pent 1 ion, 5 chloro pent 1 ion. So pent we are writing, it is not pentane. So pent ANE we are removing because there is only one triple bond, and ion we are adding here. So pent 1 ion. And if the name of this compounds, if you look at, so 1, 2, 3, 4, 5, 6, 7. The branching is at this and this also, but this is a functional group, so numbering will start from this end so that this carbon get lowest possible number. So 1, 2, 3, 7 carbon atoms in the main chain, and we see 5 methyl at the fifth position. There is one substituent, the methyl group, so it will become 5 methyl heptane 3 all, or people sometimes also write 3 heptanol. That it is heptane 3 all. That is a better way to write. So 5 ethyl heptane 3 all. Now this compound name. So again the numbering will start from here because OH is more reactive than double bond. So 1, 2, 3, 4, 5, and what we see, the 5 carbon atoms. So fifth it will paint, and the third position in paint 3 in, and first position O H group all. So paint 3 in 1 all is the name, and this group is now, this is the principal functional group. So 1, 2, numbering will start. So there is a 1, there is a 2, 3, 4, 5, 6, and so the 6 carbon atoms are there in this 6, and so it will become hex and 4 in. So it is 4 in and Al. Al for the this aldehyde group. So hex 4 in all. Hex 4 in all. Now this compound, again the numbering will start from the right to left, will follow this right to left because this ketone is the ketone, functional group is ketone, here it was aldehyde, and so all we have used as the suffix, and here we do write, will write ONE, and what will be this, a hexane. So actually the principal chain could be hexane, but it contains double bond. So hex 4 at the fourth position double bond is the hex 4 in, and then on group is there at the second position. So 2 on. So hex 4 into on is the name of this compound. We'll see some other examples as well and some key terms as we will see later on some questions, and we'll move forward